Today is October 22nd, 2014. This is Algebra 2, Section 3-2. It is discussing solving systems of linear equations using algebra. You learned what it looked like when equations are graphed and how to find their solutions. It's when the lines intersect one another and share the same point. That means they have one solution. If they intersect each other and are the same line, then they have infinitely many solutions. And if they do not intersect at all, i.e. they are parallel, then they have no solutions. So today we're going to figure out how to do this with using algebra. And open your book to page 116, and we will go through this together. Locate the paragraph that says substitution. One algebraic method is the substitution method. Excuse me. Using this method, one equation is solved for one variable in terms of the other. Then this expression is substituted for the variable in the other equation. So right below this paragraph is example 1, solved by using substitution. It says, use substitution to solve the system of equations. And remember, when we solve these, we need to find a coordinate for x and a coordinate for y, and the solution will be an ordered pair, x comma y. So the two equations are x plus 2y equals 8, and 1/2 x minus y equals 18. So the book decides it wants to solve the first equation for x. So solve the first equation for x in terms of y. That just means let's get x all by itself. So to do that, we have to subtract 2y from both sides, and we get x equals 8 minus 2y. So now we have a solution. We have we have a value for x in terms of y. So the way we figure out what the x value is we plug what we got in for x into the second equation, 1/2 x minus y equals 18. So look where it says substitute 8 minus 2y for x in the second equation and solve for y. Okay, so the x is next to the 1/2, so it's 1/2 x minus y equals 18. But remember, x is now 8 minus 2y. So what we do is say 1/2, open parens, 8 minus 2y, close parens, minus y equals 18. All we did is put 8 minus 2y in for x. So then you distribute. 8 minus 1/2 is 4, minus 2y times 1/2 is minus y. And then we have another minus y from the outside, equals 18. So minus 2y equals 14 because they combined the two y's. Minus y is negative 2y. And they subtracted 4 from both sides. So therefore, minus 2y equals 14, y equals negative 7. Whew! We did a lot of work to figure out the coordinate of the y coordinate of the solution. So to figure out what x is, all we need to do is plug in negative 7 for y in one of our original equations. So we just plug in negative 7 into, say, the first one, the top equation, x plus 2y equals 8. So we plug in negative 7 for y and get x plus 2, open parens, negative 7, close parens, equals 8. Because we just put negative 7 in for y. And when we solve that, we get x minus 14, because a positive 2 times a negative 7 is negative 14, equals 8. So we get rid of 14 by adding it to both sides, so therefore x equals 22. So our solution is 22, comma, negative 7 in the ordered pair. Next, take a look at the top of the next page is an example 2, where we're going to solve by substitution in a word problem. Now, the thing is, this is a problem where you have to figure out what both the equations are. when you read the problem. So it says, Matthew stopped for gas twice on a long trip. The price of gasoline at the first station where he stopped was $1.46 per gallon. At the second station, the price was $1.55 per gallon. Matthew bought a total of 36.1 gallons of gas at the first station, and he spent a total of $54.29 altogether. He bought a total of 36.1 gallons of gas, and he spent a total of $54.29. So then it says, write and solve a system of equations to find the number of gallons of gasoline he got at each store. Matthew bought at each gas station. Show your work, of course. So take a gander. It says, how do we figure out what types of equations we have? Well, we know that we have to deal with money, and we also know that we have to deal with the number of gallons of gas. What we don't know is how many gallons of gas he bought at each station. So to find that out, we have to create a system of equations. For the number of gallons will be one of them, and how much money he spent will be the other. So in this case, X and Y can represent the different gas stations and how many gallons he bought at each gas station. So for instance, the first equation is X plus Y equals 36.1, because 36.1 was the total number of gallons of gas that he bought. But we don't know how many he bought at the first store, so we'll say he bought X. And we don't know how much he bought at the second store, so we'll say plus Y. So the total of all those equals 36.1. That being said, we can figure out what the second equation is for dollars, because we do know that $1.46 per gallon at the first store, and it costs $1.55 at the second store. And we also were given the total number of dollars he spent. So for instance, again, we don't know the number of gallons he bought at the first store. So we say, okay, he spent 1.46x worth of dollars, because it's however much per gallon times the number of gallons he bought, plus 1.55 times Y, since Y is the number of gallons he spent or bought at the second store, and each gallon cost $1.55. Those two things added together equals the total of 54.29 that he spent altogether. You can see this after step 1 in the example. So now we just do what we did before and solve it by substitution. It is much easier to use the second equation to solve for a variable, because there is no decimal to deal with, right? So take a look at step 2. Solve one of the equations for one of the variables in terms of the other. So since the coefficients of y is 1, it makes sense to solve the first equation for y, which is exactly what I just said. So write down x plus y equals 36.1 and solve it for y. Well, to do that, all we need to do is subtract x from both sides, and we get y equals 36.1 minus x. Okay, now we take what we got for y and plug it into the second equation, the money equation. So look at step 3, where it says substitute 36.1 minus x for y in the second equation. Well, they do that for us. The second equation, again, is 1.46x plus 1.55y equals 54.29. Well, we got to plug in our thing for y, so we get 1.46x, that doesn't change, plus 1.55 open parens 36.1 minus 1 close parens equals 54.29. So all we did is substitute in that 36.1 minus x in for y. And when we do all the distribution, we get negative 0.09x equals negative 1.665. So to get x all by itself, all we need to do is divide by negative 0.09, because that's how we undo a multiply. And we get that at the first store, he bought x equals 18.5 gallons. How do we figure out how many he bought it at the second store? Well, we just plug in 18.5 into the first original equation, x plus y equals 36.1. Okay, so to do that, you just say 18.5 plus y equals 36.1. Well, how do we get y all by itself when something is added to it? We subtract. So y equals 36.1 minus 18.5, which is 17.6. So now we have our solution. Our solution is 18.5 for x and 17.6 for y. So he bought 18.5 gallons at the first store and 17 2/3 or so gallons at the second store. So to write your solution, you'd open your parens and write 18.5, comma, space, 17.6. And write a little sentence in the terms of in the context of the problem. As in, Matthew bought 18.5 gallons at the first store, and he bought 17.6 gallons at the second store, and then that would be the solution to the problem. All right. Now, turn the page or find your page break, and we will talk about another way to solve systems of equations. It is known as elimination. This involves figuring out a way to manipulate both equations to get rid of one of the variables. So there's a paragraph at the top of this page. It says, another algebraic method is the elimination method. You eliminate one of the variables by adding or subtracting the equations. When you add two true equations, the result is a new equation that is also true. Because remember, when we add or subtract or do something to any equation, you have to do it to everything in the equation to keep it true. So if we add two equations together, it doesn't change anything about it. It just makes a new equation. So let's look at example 3, solve by using elimination. We use the elimination method to solve the system of equations. Well, our two equations are 4a plus 2b equals 15, and 2a plus 2b equals 7. Now notice, do some of the coefficients match? Does the coefficients for a, do they match? No, we got a 4 and a 2. They certainly do not match. Does the coefficient for b match? Sure, we have a 2b and a 2b in both equations. That's what you want to look for when you're using elimination, figuring out a way to make the coefficients match for the same variable. So in each equation, the coefficient of b is 2. If one equation is subtracted from the other, the b's will cancel out. So take a look at the spatial problem they have here. They wrote 4a minus 2b equals 15 on top, and below they wrote 2a plus 2b equals 7. That way you can move your finger up and down and subtract. 4a minus 2a is 2a. 2b minus 2b, well, that goes away, that's nothing. And 15 minus 7 is 8. So now we have a new true equation, 2a equals 8. Well, how do we solve that for a? We just divide everything by 2. A equals 4. Hooray, we figured out what a is. That's great. Now we use what we learned from the prior two examples. Now that we have a value for one of our variables, all we need to do is plug it into one of the original equations. The book chose to plug a into 2a plus 2b equals 7. And they did that because the coefficients are smaller in that equation. Both of them are 2. It doesn't matter which equation you plug it in. You can choose. That is perfectly okay. You're still going to get the same answer. So let's plug in 4 for a. 2a plus 2b equals 7 is the same as 2 times 4 plus 2b equals 7. 2 times 4 is 8, so now we have 8 plus 2b equals 7. We get rid of 8 by subtracting it, so we have 2b equals 7 minus 8, or 2b equals negative 1. So b, therefore, must be negative a half, because we have to divide by 2. So your solution solution ordered pair is 4, negative 1/2. So the next thing we have to do is, what if it's not so pretty? What if our two equations don't have a matching coefficient for the same variable? Well, then we have to manipulate one of the equations to make it work. So see the paragraph where it says sometimes? Sometimes adding and subtracting the equations will not eliminate a variable. You may use multiplication to write an equivalent equation so that one of the variables has the same or opposite coefficients in both equations. When you multiply an equation by a non-zero number, the new equation has the same set of solutions. Because remember, if you multiply an equation by a number, it remains the same as long as you multiply everything in the equation by that number. So let's look at example 4. It says multiply, then use the elimination method. So use the elimination method to solve the system of equations. Well, our two systems of equations are 3x minus 7y equals negative 14. 5x plus 2y equals 45. Okay, so we have a 3x and a 5x, a negative 7y, and a positive 2y. Oh boy, they do not match, do they? We got to figure out a way to make them match. So the book wants to match up the, let's see here, the y's. So how do we get a 7y and a 2y to match up? Well, to do that, it's kind of like solving for a common denominator. What is the common multiple, the least common multiple of 7 and 2? Well, it's 14. So finding how they match is kind of like finding a common denominator. What is the common number we can find so we can get rid of these, so we can add or subtract and get rid of a variable? Well, how do we get a 7y to be and a 2y to match up? Well, the closest that both go into is 14. So to get the 7y to be 14, we got to multiply the first equation by 2. The second equation has a 2y, so how do we get 2y to be 14? Well, we multiply the second equation by 7, because 2 times 7 is 14. And they did this below the two equations, where it says multiply the first equation by 2 and the second equation by 7. So 2x minus 7y equals negative 14, and 5x plus 2y equals 45. They did it for you in another spatial format. They did it for you on the right. So for instance, 3y minus 7y equals negative 14. When we multiply that by 2, we get 6x minus 14y equals negative 28. Further, when we have 5x plus 2y equals 45, and we multiply that by 7, we get the bottom equation, 35x plus 14y equals 315. So if you find the spatial problem in your textbook, it says those things, and we just add them together because we have a negative 14y and a positive 14y. And the way we get rid of those is by adding them, because that will become 0. So 6x plus 35x becomes 41x. Negative 14y plus a positive 14y is 0y, so there's nothing there. And negative 28 plus 315 turns out to be 287. So you end up with a new equation, 41x equals 287. Well, turns out that x equals 7 because 287 divided by 41 is 7. Whew, after all that work, it took that much work to get one x value. Well, remember, once you have a value, all you need to do is substitute it into one of the original equations. So you just substitute 7 in for x, and the book chose to do it in 3x minus 7y equals negative 14. But let me rephrase. Only substitute in the value you got into your original equation, not one of the ones you multiplied. It'll make your life a little easier. So 3x minus 7y equals negative 14. Plugging 7 in for x gives 3 times 7 minus 7 times y equals negative 14, or 21 minus 7y equals negative 14. We subtract 21 from both sides and get negative 7y equals negative 35. Y then divided by, 35 divided by negative 7 is 5. So y equals 5. And that means we finally reached our solution of 7, 5, the ordered pair 7, 5. That's where these two lines cross. They cross at the point 7 to the right on the x-axis and 5 up. Whew. Okay. Take a look at the top of the next page. It says, if you add or subtract two equations in the system of equations and the result is an equation that is never true, something like 2 equals 5. 2 equals 5 is never true, right? We can never have 2 cookies be the same as 5 cookies. So when that happens, then the system of equations is inconsistent and it has no solution. Oh, it has no solution. Okay, remember what that meant? It meant, oh, the lines must be parallel because they will never ever cross. So if the result, if the result when you add or subtract equations is a system is an equation that is always true, then the system is dependent and has infinitely many solutions. Okay, so for instance, if we got a solution that said, when we solved and did all our elimination and substitution with two equations, and we got something that said 5 equals 7, that would tell you right away that there's no solution, because that doesn't make any sense. That would mean it's inconsistent. It doesn't make any sense. However, if we got something that said, when we did all our substitution and elimination, and we got something that said 1 equals 1, then that's always true, isn't it? 1 is always the same as 1, isn't it? One cookie, same as another cookie, right? So, if you get something that says 1 equals 1, then you know you have infinitely many solutions because that little teeny equation is always true. Let's check out what they mean in example 5. Inconsistent solutions. So, use the elimination method to solve the system of equations. 8x minus 2y equals 17, minus 4x minus y equals 9. So, what do we want to match up? Well, it looks to me we have a 4x and a negative 4x. We have a 2y and a negative y. Well, we can already see that 4 is a factor of 8. So we don't have to change the top equation if we multiply the bottom one by 2, right? Because 8x or 4x is a multiple of 8x, isn't it? So what we do is we have our equations and we multiply the bottom one by 2 so that we can get the negative 4x to be an 8x of some kind. Doesn't matter if it's positive or negative, because if it's a positive, you can add the equations, and if it's a negative, if it's the positive equations, you can add them. Okay, if both equations have positive matching numbers, then you can subtract them. If, however, your equations have opposite signed numbers, coefficients that are the same, then you can subtract them. Whatever it takes to get them to be 0. So the book did this for you in another spatial problem. Should be a bit down the page. They left the top equation alone, so it just says 8x plus 2y equals 17, but they multiplied the bottom equation. So negative 4x times 2 is negative 8x, and negative y times 2 is negative 2y. So the bottom equation says negative 8x minus 2y equals 18. When we add these equations together, 8x minus 8x, well, that's 0. 2y plus negative 2y is also nothing, right? 2 plus a negative 2 is nothing. So we have no more y variables either, so we're just left with 0. And then when we go past the equal sign, we have 17 plus 18. Well, 17 plus 18 is 35. So on the left, we were left with a 0, and on the right, we were left with a 35. Well, 0 equals 35. Does that make any sense? No. So right away, that should tell you that this system of equations has no solutions. It is therefore inconsistent. So for you, I would like you to do 4 and 5. 4, 5, and 6. Stormy, just do problems 4, 5, and 6. And please let me know if you have any questions. And I will publish this right now and send it to you ASAP.